Hello everybody, today you learn how to measure the performance of code. What does performance means? Performance means how well something works. In case of programming, we want to check how well, for example, that part of code works. So how fast that code is. And well, in the last lecture, we created 5 solutions to the same problem. The results were the same, but we don't know how fast they are. Well, we can guess, right? But are our guesses always the best way to choose what we should use? Maybe it's better to measure it, right? When we measure it, we're gonna be 100% sure that everything works fine. So, how to do it? How to approach a problem like that? Well, we need to import the library that is called time. And this library has functions like every other module. And here we have got something what is called perf counter. Performance counter. Perf is a shortcut for performance. It returns the value of a performance counter that can measure a short duration. So it's gonna give us a time, a counter when something happened. How can we use it for checking measuring the performance of code? Look, this thing happened here, this line of code, right? This line of code happened here. And this line of code happened here. So we could, for example, invoke it before it happened, right? So we could do something like time that performance counter. And now we're gonna have as a result that we can save it in the variable that we call start, the beginning when something happened. And we can also save the end when something ended, right? So here we invoke the performance counter. We have got the time when something happened. And then we invoke, well, computer invokes the print. Then he needs a result for the print. So he goes into sum up to, he sends the value here. He does whatever he must in order to count the sum. He returns the sum and he comes back here. He prints it and then we check how long it took. Well, we don't check how long it took. We just insert here. We just get the time when it finished, right? So when we have a time when something finished and the time when something began, when something started, we can just do something like that, right? And minus start. And we can save it to, for example, or we can just print it, right? Instantly. So that's how long it took, right? And minus start. And when we run the module, as you can see, as a result, we have got 0.0047. And this number is here in seconds. So it means that it took only 4 milliseconds. 1 second is 1000 milliseconds, okay? So it took 5 milliseconds. When we run this module again, as you will see, there is a small difference here, right? Here is 7, here is 3. When we run the module again, here is 4. So every time we run this module, the result might differ. As you can see, here is even 5 milliseconds, almost 6. And why it happens? Well, look, our processor right now might be working on something. Like, for example, in my case, it's working on recording. It has got also lots of applications in the background, right? I have got lots of folders opened. So there is lots of work in the background. And that's why the results might be different each time we run the module, right? But don't worry about these differences, right? When we, for example, do, the same thing here for the second guy, As you can see, well, here is even 8 milliseconds now. As you can see, even though we run this module each time, the results are different, right? But, well, what is faster is still faster, right? This thing is faster each time. So even if we run this module lots of times, the thing that was faster is faster. So don't worry about it. So we mostly want to, well, we could even run this, for example, 100 times, right? And then check if, just in case, right? Because sometimes maybe there would be an error. But as you can see, you can, count on this method if you run it enough times, at least. So when we run the module, as you can see, each time at least the guy here, so the sum up to is faster than sum up to here. So the result that we can see depend on how busy the processor is by the applications and programs that are running in the background, right? And also how good the processor is. Remember that, well, I have got right now a result like that. You might have a better processor than me, or you might have a worse. So your results might be different also, right? But it doesn't matter because the ratio between the two scripts should be similar among different computers. So what is faster or slower should be the same. Now I will show you something very cool. When I add here 5 and here 5, what will happen? As you can see, the method 2 is faster. What will happen when I add one more 5 here? One more 5 here. This guy got slower. One more 5. Oh, this guy is slower now than this. What happened here? Let's increase it even further, like that. Run the module. As you can see, it takes lots of time now. 2.4. 3.0. Why? Why now this method is slower when it was faster? Because that's how it works on big numbers, on big amount of allocation that you need to process, right? Because notice that here, in case of sum up to, right, in case of that here, we allocate now, so we reserve enormous amount of places in our computer. Here, we do not need to reserve numbers. We just get them from the range function. We add them and we just forget about them. So that thing, when there is a big amount of numbers to use, is faster. So when you are a programmer, you need to think what values you're gonna get from users, right? Let's run the performance on other cases. So let's do something like that. Sum up to 3, 4, and 5. Let's see which method was the fastest. 2.3 for the first guy. 3.0, 3.3. Ooh, 3.1, and then what? Instant result. Sum up to 5 is just instant. Why? Because, well, here comes the number is added to 1, this result is divided by 2 and just multiplied by the amount of numbers. That's just so fast, right? So when, as you can see, sometimes you can get really a big difference when you know, for example, math, like, for example, how arithmetic sequences work, right? So you can sometimes guess what is faster, right? Like for example, in case of 5, it's really easy to see. But when you look at the situation 2, 3, and 4, you might not be 100% sure. And that's time when you can really just check how fast something works using the measuring performance of code methods like that, right? Time that performance counter at start, then at the end, and minus start, and you know exactly how fast something is. It's also worth to notice that when numbers are small, so when we do something like that, the differences are very small. Even as you can see here, we have got, the fastest method is almost as fast as the method 2, right? Or the third method, right? Now, when you are doing things on small amount of things, well, you would need to repeat it probably 100 times to even notice the difference, right? Maybe even thousands of times. So when you are working on small things, and 300 seems a lot, right? If I told you to count to 300, it would take you some time. For a computer, as you can see, it's pretty fast. So when you are working on small values, sometimes it's better for you, right, to focus on just how your program will look, not how fast it is. Okay? Do not overdo it, that your program must be the fastest possible, because, well, if some part of your code is not used very frequently, then why even bother about, optimizing it, so making it perform better? It's better to focus on how it looks, so it's gonna be easier to use by you and by other programmers. It's also gonna give you more benefits, right? Because, well, we could, for example, instead of returning the sum, we could, save the generated numbers, right? The generator here, something like that. For example, like that, right? And we could, return the generator instead or whatever and make the sum later. So it really depends on what you want to do. In case, of something like that, when you have got 5 solutions and you want only a result, right? You don't care about, you don't need to later use the data, like in case of lists, sets, or the generator. You don't care about it, you just want a result. So, and it would be used frequently, right? Frequently, because, notice that here there is no difference almost, right? Between this solution and this solution, even though this solution has only what? 3 things to do, 1, 2, 3. Then sometimes it's better to look at just how it looks. Of course, remember that this thing takes memory just for some time, right? So probably I would use this method or this, because, even though this method looks better, right? And you clearly see what it does instantly. Well, it takes space in memory just for that millisecond. So really, it depends. Always, it depends on the situation you are in. And you are a programmer, and you should decide what your situation is. It's not like you're gonna ask me forever what you should do. As you can see, even when I'm talking about it, sometimes I'm getting into new ideas, right? And because of that ideas, I might change my perspective on what should be used in case like that, in case like that, in case like that. It depends. And when you are not sure, you can check how fast something is, if really you care about the speed, or maybe it's worth to ask somebody, for example, Stack Overflow, what you should use, what is better in that situation. In time, you will get experience and you will decide better, right? What is more important for you, the cleaner code or maybe how fast something is. Okay, that's only the lesson. Thank you very much.